Let's try another example using mathematical induction. So use mathematical induction to prove this formula: S sub n equals 1 squared plus 2 squared plus 3 squared plus 4 squared plus ... plus n squared equals n times n plus 1 times 2n plus 1 over 6 for all integers n is greater than or equal to 1. So we do the same thing that we did previously. We first have to prove that when we plug in 1, so S sub 1, so number 1, when n equals 1, the formula is valid. Because when you plug in S sub 1, so we're plugging it in again into this formula here. So 1 times 1 plus 1 times 2 times 1 plus 1 over 6, that should equal the first term of 1. So this is plus 1. This is 1 times 2 times 3 over 6, which is 6 over 6, which is 1. So we did prove that that is true. So number 2, assume that the formula S sub k, so that's going to be 1 squared plus 2 squared plus 3 squared plus 4 squared plus n squared equals, oh, it's not n, it should be k squared, plus k squared, that equals k times k plus 1 times 2k plus 1 over 6 is true. We're assuming that that formula is true. We need to show that S of k plus 1 is going to equal, and so we plug in the k plus 1 into every k that we have up here. So this is going to be k plus 1 times k plus 1, and then plus 1, and then times 2 times the k plus 1 plus 1 all over 6. So we need to simplify this to see where we're headed and what we're trying to do. So this is k plus 1 times k plus 2, and this is 2k plus 2 plus 1. So this is going to be 2k plus 3, and that's all over 6. So S of k plus 1, we're trying to show that this is true. So our goal is to get to this here. Okay, we want it to look like this. So then we do the proof here. So then when we have S of k plus 1, we take that value first from the very beginning right here, and we write that. So we write 1 squared plus 2 squared plus 3 squared plus 4 squared plus ... plus k squared plus, and this is where we add the k plus 1 to the k squared here. So then we write k plus 1 to the square. Now we substitute. So we know that this is our S sub k. So S sub k plus 1 equals S sub k. And then this is going to be plus this k plus 1 squared. Then we substitute that S sub k. S sub k is this here, so let's substitute that part. So that is going to be k times k plus 1 times 2k plus 1 all over 6. And then we have our plus, parentheses, k plus 1 squared. So now it's just algebra involved. So now in order to combine these fractions, or combine these two terms, we need to get a common denominator. So let's multiply this side by 6 over 6. So now this is k times k plus 1 times 2k plus 1 plus 6 times k plus 1 squared all over the common denominator of 6. Now, just looking at where we're headed and what we want, so I want a k plus 1, and then if I'm looking at these values here, I notice I have a k plus 1 and a k plus 1. So what we're going to do is go ahead to factor out a k plus 1 to the front. Okay, so I'm just factoring out one of the k plus 1s here. So now we're left with k times 2k plus 1 plus 6 times k plus 1. And so what we're going to do is, oh, and that's all over 6. So let's go ahead and simplify what's in the parentheses here. So we're going to multiply it through k plus 1. And then this is going to be 2k squared plus k plus 6k plus 6 all over 6. And then this is going to be k plus 1 times the 2k squared plus 7k plus 6 all over 6. And so that 2k squared plus 7k plus 6, that is factorable. So k and 2k, so what multiplies to 12, that adds to 7, that's 4 and 3. So 2, 3 here. So k plus 1, k plus 2 times 2k plus 3 over 6. And let's go back and look. Is that what I wanted? Yes, that's exactly what we needed. So notice that it is true. We got this that we said should be true here. So therefore, by mathematical induction, the formula is valid for all integers n greater than or equal to 1 or all positive integers. So now try this example here, s sub n, here, that should equal that formula, so try this out. So trying this out, hopefully you got the same answer here, just some algebra involved, substituting and putting things in the right place and so forth. And so this is the work that you need to show. You do have to show this part here. You can't just show me this ending part here. You have to write this whole thing, what s sub k is, substitute, and then get a common denominator and so forth, and writing this at the end.